Lately, I've noticed my charging system hasn't been putting into my battery what my lighting system's been taking out. And frankly, my little Lucas amp meter just leaves me guessing. So today, we're going to find out exactly what's going on inside this charging system. The quickest way to check if there's charging going on or not is to insert an amp meter between the battery lead and the battery terminal. With the engine running, current will show up on your amp meter as either flowing into or out of your battery. If current isn't flowing into your battery, then the charging system isn't doing its job. And without the help of the alternator, your battery will quickly fade along with your light. My meter reads no current flowing into the battery, so that's enough for me to conduct further testing per the Triumph Workshop Manual. The first test will check the DC output at the rectifier. Now the manual points out that a well-charged battery in good condition is necessary for accurate test results. Disconnect the center lead from the rectifier, which on my bike is brown and purple, and hook up the amp meter in series. That is, with one lead, the red positive lead on the wire lead, and the black negative lead on the center terminal of the rectifier. With the amp meter hooked up this way, a positive reading will indicate current flowing toward the battery, and a negative reading will indicate current flowing from the battery. Start the motorcycle, and with the lighting switched off, rev the engine to about 3,000 RPM, or about the engine speed of about 45 miles an hour in top gear. Take a look at the meter and record the current reading. Be sure to notice if the number is positive or negative. Now, switch the lighting to pilot. Again, look at the meter and record the number, positive or negative. Finally, turn the lighting switch to main beam and record the meter reading. According to the workshop manual data for my alternator type, stator part number, and system voltage of 6 volts DC, the DC output from the rectifier to the battery should be 2.75 amps. And with the pilot or headlight on, 2 amps. My test measured 0 amps. These test results don't look good, so it's on to the next test where we'll check the alternator output directly. I'll first find the alternator output leads and disconnect them at the bullet connectors. My alternator has 3 leads. The workshop manual tells me to connect an AC voltmeter with a 1 ohm load resistor in parallel with each of the alternator leads in turn per the table in the manual. Now the workshop manual actually tells you how to make a 1 ohm load resistor, but I was able to easily find on the internet a 1 ohm, 100 watt, very precise 2% load resistor for under 15 bucks. I've mounted the resistor on non-conductive material for easy handling. I'm not sure how hot this thing's going to get, so I don't want to have to hold it. I'm also going to add a switch to the circuit, just because I can. Finally, I've tied it all together with 14 gauge wire. The load that we'll be creating with this resistor circuit will allow us to test the alternator under measurable operating conditions. With the test circuit built, we can check the alternator output. With the engine running at about 3,000 RPM, the table tells us to measure the AC voltage between the green and white and green and black alternator leads. I'll flip the switch on to complete the circuit and record the meter reading. Next, we measure the voltage between the green-white and green-yellow leads and record the voltage. Last, we'll measure the green-white and green-black and green-yellow leads connected and record that reading. The readings I took jive with the values in the table, confirming that the alternator is okay. Next, I'll check the rectifier. The first test can be done with the rectifier in place. The manual says to first disconnect the brown-white lead from the center terminal of the rectifier. A piece of electrical tape on the end of the lead will prevent the possibility of a short. We'll connect a DC voltmeter parallel to our 1 ohm load resistor, with the voltmeter negative lead to the center terminal of the rectifier and the positive lead to ground. Disconnect the alternator green-yellow lead and connect it to the rectifier green-black terminal using a jumper. Fire up the engine, rev to 3,000 RPM, and record the voltage on the meter. Now, according to the workshop manual, the voltage coming out of the center lead of the rectifier should be at least 7.5 volts DC. I'm reading 0. But that still leaves a couple of wires and the rectifier as possible culprits. It looks like there are only 2 wires that could cause this symptom, and that's the 2 wires from the alternator to the rectifier. And then there's the ground connection. So I'm just going to check these 2 wires for continuity and short to each other and to ground. And then also make sure that the rectifier is mounted properly, providing a good ground. Well, the wires have continuity, and they aren't shorted to each other or ground. So I've pulled the rectifier for a bench test. The bench test will use the same load circuit as we used on the other tests, but we'll also need a 12-volt automotive battery. The workshop manual tells us to connect a 1 ohm load resistor in series between the positive battery terminal and a lead that will go to the rectifier. A second lead will connect the negative battery terminal to the rectifier. I also still have my switch in series, which will help reduce the time the voltage is applied to the rectifier to avoid overheating it. With the test leads, I'll make a series of connection combinations specified in the workshop manual. There are 4 combinations, and we'll record the voltage for each. Then, we'll reverse the leads and repeat those combinations, recording those voltages as well. The rectifier uses a series of diodes to convert AC electricity, generated by the alternator, into DC electricity needed to charge the battery in this case. Now the bench test is designed to check forward resistance and back leakage. And if any one of these 8 measurements are out of tolerance, then the rectifier's trash. And I can tell you, every one of these was bad. Really bad. With the new rectifier installed, it's problem solved. There's a few options out there for upgrading your stock system with more modern components. Most involve converting to 12 volts. But if you want to stay stock, your Triumph Workshop manual, a multimeter, and a few electrical parts is all you need to keep it running strong.